Okay, hello everyone. Today we will going to see some practice questions from the chapter solution, and this is our part 2. So let's start. Disclaimer slide which says the images used in our slide deck are for educational purposes only. We respect the intellectual property rights of the original creators and owners of these images. If you are the owner of any of the images used in this deck and have any concerns or issues, please contact us at sathee@iitk.ac.in and we shall remove the images. Let's start with our index slide. So we will going to see some practice questions from question 11 to question 20. Let's start with the question number 11. Vapour pressure of pure benzene is 119 torr and that of toluene is 37 torr at the same temperature. Mole fraction of toluene in vapor phase, which is in equilibrium with the solution of benzene and toluene having a mole fraction of 0.50 will be. So we have to find out the mole fraction of toluene in vapor phase. And vapor phase of pure benzene is given. Vapor pressure of pure benzene is given 119 torr and toluene is also given 37 torr. So options are 0.137, 0.237, 0.435 or 0.205. So you have 10 seconds to solve this question. After that, we will see the answer. Okay, so the correct answer is B option. So from Raoult's law for an ideal solution, we know that the total pressure is equals to the sum of multiple of vapor pressure and mole fraction of the components. So we have benzene and toluene. So we have to put the values given in the question in this equation. So we have P total as 78 torr and mole fraction of toluene in vapor phase is calculated as the vapor pressure of total solution multiplied by the or sorry, not total, toluene, the vapor pressure of toluene into mole fraction of toluene divided by the total pressure, and it is 18.5 divided by 78. As total pressure we have calculated 78 and 18.5 is the vapor pressure and the mole fraction multiplication we have calculated from this, right? And the fraction is coming out as 0.237. Hence, option B is the correct answer. Okay, let's move to question number 12. On mixing heptane and octane, form an ideal solution at 373 Kelvin. The vapor pressure of two liquid components, heptane and octane, are 105 kilopascal and 45 kilopascal respectively. So for heptane 105 kilopascal, for octane the vapor pressure is 45 kilopascal. Vapor pressure of the solution obtained by mixing 25 gram of heptane and 35 gram of octane will be. So we have to calculate the vapor pressure of solution. Molar mass of heptane 100 gram per mole and octane 114 gram per mole is given. Options are 72 kilopascal, 36.1 kilopascal, 96.2 kilopascal, 144.5 kilopascal. So you have 10 seconds to solve this question. After that, we will see the answer. Okay, so the correct answer is option A. So we know that total pressure is given by the mole fraction of heptane into vapor pressure of heptane plus mole fraction of octane into vapor pressure of octane. And we have to calculate the mole fraction of heptane, right? So for the calculation of mole fraction of heptane, we can calculate it by putting the number of moles of heptane divided by the total moles in the solution, and the mole fraction is coming out as 0.45. So mole fraction of octane will be 1 minus 0.45 because the sum of mole fractions of solution, that is solute plus solvent, will be 1. So 1 minus 0.45 is the mole fraction of octane, which is 0.55. Now we put these two values in this equation. So we have total pressure is 0.45 into 105 plus 0.55 into 45, and it is coming out as 72 kilopascal. So total vapor pressure of the solution is 72 kilopascal, and it is the thing which has asked in our question. So option A is the correct answer. Okay, so let's move to question number 13. A binary liquid solution is prepared by mixing N-heptane and ethanol. Which one of the following statements is correct regarding the behavior of the solution? So we have given some statements in the options and we have to find out the correct statement. The solution formed is an ideal solution. The solution is non-ideal, showing positive deviation from Raoult's law. The solution is non-ideal, showing negative deviation from Raoult's law. Or N-heptane shows positive deviation while ethanol shows negative deviation from Raoult's law. So you have 10 seconds to solve this question. After that, we will see the answer. Okay, so the correct answer is B option. That is, correct answer is this. So the solution will be non-ideal and it will show the positive deviation from Raoult's law. So N-heptane and ethanol, which is given in the question, N-heptane and ethanol. N-heptane and ethanol forms non-ideal solution. So half of statement will be correct. As a result, N-heptane and ethanol molecular interaction is very poor in comparison to ethanol-ethanol or N-heptane-N-heptane interaction. So, the resulting solution gives positive deviation from Raoult's law. Hence, option B is the correct statement. Okay, let's move to question number 14. If two liquids A and B form minimum boiling azeotrope at some specific composition, then, so you have to select the correct one. AB interactions are stronger than those between AA or BB. Vapor pressure of solution increases because more number of molecules of liquids A and B can escape from the solution. Vapor pressure of solution decreases because less number of molecules of only one of the liquids escape from the solution. AB interactions are weaker than those between AB or BB. So you have to select the correct one and keep in mind that A and B are two liquids forming minimum boiling azeotropes. So, okay. And one more hint that minimum boiling azeotrope and positive negative deviation from Raoult's law. Okay. So you have 10 seconds to solve this question. After that, we will see the answer. Okay, so the correct answer is option A. Minimum boiling azeotrope show positive deviations from Raoult's law due to stronger solute-solute interaction. So in the positive deviation solutions, we have solute-solute interactions stronger than the solute and solvent interactions. Hence, option A is the correct statement, is the correct answer. Okay, let's move to question number 15. An unknown compound is immiscible with water. It is steam distilled at 98 degrees Celsius. At 98 degrees Celsius, the P total and pH2 or total vapor pressure of H2 are respectively 737 and 707 torr. This distillates was 75% by weight of water. The molecular weight of unknown compound is. Options are 318.15 gram per mole, 300 gram per mole, 306.76 gram per mole, or none of these. So you have 10 seconds to solve this question. After that, we will see the answer. Okay, so the correct answer is option A. Since unknown compound is immiscible with water as given in the question, hence vapor pressure is directly related to the number of moles. So we have given that the total vapor pressure is 737 and the pressure or vapor pressure of H2 is 707 torr. So vapor pressure of unknown compound will be this total minus vapor pressure of H2. That is 737 minus 707, which is 32. And if we find out the ratio of the vapor pressure of unknown to vapor pressure of water, we have which is equals to number of moles fraction of unknown compound and water. And number of mole, we know that the molecular given weight upon molecular weight. So weight of unknown into molar mass of H2 divided by weight of H2 into molar mass of unknown. And on putting the values in this equation, sorry, not it will not come here. Here is this, yeah. So from this equation and on putting this the value in this equation, we have 30 upon 707, that is the pressure, vapor pressure, is equals to the weight of unknown, that is 75, into molar mass of H2, that is 18, divided by 100 into molar mass of unknown compound. So from this, the molar mass of unknown compound is calculated as 318.15 gram per mole. Okay, hence option A is the correct answer. Okay, let's move to question number 16. The relative lowering of vapor pressure of an aqueous solution containing a non-volatile solute is 0.0125. The molality of the solution is, so we have to find out the molality. Options are 0.69 molar, 0.50 molar, 0.80 molar, or 0.40 molar. So you have 10 seconds to solve this question. After that, we will see the answer. Okay, so the correct answer is option A. And we know that the relative lowering of vapor pressure is equals to the mole fraction, and we can write it as molality into the M1 upon 1000 plus molality into M1. And for the dilute solution, we know that 1000 is really greater than the M into M1, right? In denominator. In denominator, 1000 is really greater than M into M1, because for dilute solution, the volume of solvent is really higher. So the relative lowering of vapor pressure is equals to molality into M molar mass upon 1000, that is the volume. And on putting every value, we have 0.0125 of relative lowering of vapor pressure. So we write it at left hand side. And molality, we have to find out into 18 water molar mass upon 1000. So molality is coming out as 0.69 molar, right? So option A will be the correct answer. Okay. So let's move to question number 17. The vapor pressure of water at 20 degrees Celsius is 17.5 mm of Hg. If 18 gram glucose is added to 178.2 gram of water at 20 degrees Celsius, the vapor pressure of resulting solution will be. So we have to find out the vapor pressure of the resulting solution. So options are 16.5 mm of Hg, 17.325 mm of Hg, 17.675 mm of Hg, or 15.750 mm of Hg. So you have 10 seconds to solve this question. After that, we will see the answer. Okay, so the correct answer is option B. So the relative lowering of vapor pressure is equals to uh, the fraction or mole fraction, right, or the molar mass fraction. So we can write the W2 upon M2. W is the given mass, M is the molar mass upon the total moles in the solution. P naught is given as 17.5 minus P1 is we have to calculate divide by P naught, which is again 17.5, and given mass 18 divided by the molar mass 180 and of glucose, and divide by the the given mass of water divided by molar mass of water plus the number of moles of glucose. And on solving these two, left hand side and right hand side, we have P1 value, or the vapor pressure of resulting solution value will be 17.325 mm of Hg. So option B is the correct answer. Okay, let's move to question number 18. A and B are ideal gases. The molecular weight of A and B are in the ratio 1:4. The pressure of a gas mixture contain equal weight of A and B is P atmosphere. What is the partial pressure of B in the mixture? Options are P by 5, P by 2, P by 2.5, or 3P by 4. So you have 10 seconds to solve this question. After that, we will see the answer. Okay, so the correct answer is option A. So the molecular weight ratio of A and B is given as 1:4. So we can say that the mole ratio of A and B will be 4:1. If we take the equal weight, because equal weight we have given that they are of equal weights, right? So molecular weight is number of moles is given mass upon molar mass. So molecular weight will be given mass upon moles. So mole will be the inversely proportional or inversely related to the molecular weight. So 1:4 will become 4:1 for A and B. And the partial pressure of B will be equal to total pressure upon the mole fraction. And total pressure is P as given in the question. And the mole fraction is calculating as 1/5 or 5. As if we take 4x or 1x as the mole ratio of A and B, then the mole fraction is coming out as 5. So it will be P upon 5 as partial pressure of B. Hence, option A will be the correct answer. Okay. Let's move to question number 19. 18 gram of glucose is added to 178.2 gram of water. The vapor pressure of water in torr for this aqueous solution is. Options are 76, 752.4, 759, and 7.6. You have 10 seconds to solve this question. After that, we will see the answer. Okay, so the correct answer is option B. Vapor pressure of water is given as 760 torr. We will take in torr, 1 atmosphere in torr will be 760. And number of moles of glucose will be mass upon molecular mass. So mass is given as 18 gram upon molecular mass is 180 gram. So it is coming out as 0.1 mole. Similarly, molar mass of water will be 18 gram per mole, and mass of water is given as 178.2 grams. So number of moles of water will be 178.2 upon 18 given mass upon molar mass, and it is coming out as 9.9 mole. So total number of moles in the solution we have 0.1 plus 9.1, which is 9.9, which is 10 mole. So we have total number of moles as 10 moles. Now we know that the vapor pressure of water will be equal to total vapor pressure into mole fraction of water. And total vapor pressure, we know that it is 760. Multiply the mole fraction of water, and on equating the number of moles of water and glucose, we have mole fraction of water as 0.99. And 760 into 0.99 is coming out as 752.4. Hence, option B will be the correct answer. Okay, let's move to the question number 20. The vapor pressure of acetone at 20 degrees Celsius in 185 torr. When 1.2 gram of non-volatile substance was dissolved in 100 gram of acetone at 20 degrees Celsius, its vapor pressure was 183 torr. The molar mass of the substance is. So, options are 32, 64, 128, 488. So, you have 10 seconds to solve this question. After that, we will see the answer. Okay, so the correct answer is option B. We have given the vapor pressure is 185 torr and of acetone and at 20 degrees Celsius, and P1 is 183 torr at 20 degrees Celsius of acetone. So mass of non-volatile substance is given as 1.2 gram. So mass of acetone, let's we take 100 gram and it is given in the question. So we have relative lowering of vapor pressure is equals to the fraction ratio of the number of moles of solute and solvent. On putting the values, 185 minus 183 upon 183 equals to given mass 1.2 upon molar mass. Divide by given mass, that is 100 gram, upon molar mass, that is 58 for the acetone. And on solving this fraction, we have molar mass is equals to this fraction. And on solving this, we have molar mass equals to 63.684, which is equivalent to 64 gram per mole. And hence, option B will be the correct answer for this question. Okay. Thank you.